Good evening, and I'm happy to say that we are continuing with our statistics, and basically this is displaying data. So now we're learning about line graphs. You guys did bar graphs, and then you did double bar graphs when we compared our monsters. And now we are going to talk about line graphs and why we use line graphs. So before we can do that, we just have to do a quick summary about bar graphs. Hopefully you'll remember all this information. Can someone, or not someone, I guess I'm not in class, so think of when we use a bar graph. We use a bar graph to compare data. Okay, usually more than one thing. It's like when we did our monsters, we were comparing monsters, and the way we collected our data is that we counted votes. So bar graphs show counted data. Okay, we actually physically took and counted up the number of votes, and then we even did more where we divided the class into boys and girls. So that is great to show because we're comparing by counting votes. So that's when you use a bar graph. Line graphs, though, are completely different. We use line to show changes in one thing over time, and is usually measured with some kind of tool, like a stopwatch or a clock or a ruler, or something that you can measure by, or a scale of some sort. So we would use line graphs to show a change. Oh, okay. My pen is not cooperating with me. Oh my goodness, that's crazy. Alright, let's try this again. Sorry guys, wasting your time. Change in one, that's key, one thing, where a bar graph is comparing many things, at least two or more, one thing over time. Okay, you can see over here we're about to make a graph showing how much our plant grew over several weeks. So that's over time. Okay, line graphs use measured data. Measured data would be using a tool, where in bar graphs you count it. Here we are going to measure it using tools. Tools like, if you guys remember, a thermometer. Okay, what else would we use? Ruler. I'm not sure I spelled thermometer right, but ruler and things like that. So those are examples of what you would use to measure data. This data, therefore, is called continuous because it's measured, and with continuous data, you can have numbers that fall in between whole numbers. So you can have your fractions and decimals, because think about our plant. Our plant is not going to grow in centimeters at a time. It might grow a centimeter and a half or a centimeter and a quarter, and that's okay, especially because we can display that on a line graph very easily. So you're going to have decimals and fractions, unlike a bar graph, which is only whole numbers, because remember we talked about how you can't have a half a person. But continuous data, you can have fractions and decimals. So basically line graphs show this kind of information. Okay, so now I have my chart of plant growth. So I had at some point collected some data on a specific plant. I used a ruler to measure the height as the weeks passed by, and now I have it in my chart here over here. And now I want to plot it because I want to see, is there a trend? Did my plant actually grow over time? So I'm going to go ahead and first of all, let's point at some things that are common in both graphs. Notice that when we do a bar graph and a line graph, we have to have a title, because we should be able to just look at the graph itself and know what it's about. Notice also that with a bar graph and a line graph, we have our axis labels, so those are very important to have. Notice also that we have scales. Our scale on the x-axis goes from 0 to 10. Our scale on the y-axis goes from 0 to 20. What you might have noticed, that these don't go up by the same amount. The interval for this axis right here is 1, so it goes up by ones, 0, 1, 2, 3, and so on all the way up to 10. Whereas on our y-axis right here, notice it goes up by 2s, 2, 4, 6, 8, 10. Our interval here is 2. So it's okay that you do that, is because you have to account for the maximum data in the chart. Notice that our weeks, I need it to go up to at least 9, and then in our height, it's got to go up to at least 14. So my graph has to include those numbers. All right, let me clean this up first. These should look a little familiar to you because this looks like a coordinate graph system. We did this at the beginning of the year. Your coordinates are basically just like this. So whenever you get a line graph, if you're more comfortable, go ahead and write the coordinates. I'm taking the x-axis or x-coordinate and putting it with the y-coordinate so that I can easily graph this. Don't need to do this, but it helps me see the points easier because I know how to graph points. All right, I'm going to start with 1, 4. I go over, then up. Remember, you can't go up the elevator until you get to it. Next one, 3, 8. Go over to 3 and up to 8. Right there. I'm now going to do 5 and 10. So far, so good. 7 and 11. Oh, there's no 11. Well, if I remember correctly, 11 falls between 10 and 12, so if I put it right down the middle, it'll be pretty close to where 11 is. And then I'm going to use 9 and 14. All right, so I'm going to connect these because our plant started out at our first week when we did our first measurement, it was already 4 centimeters high. Then we did our second measurement, it jumped all the way to 8 centimeters. So I'm just going to connect these so I can really get a good idea of what my plant growth is, or in other words, my trend. Trend. This is the word that's going to come up when you're doing your homework for line graphs. It's going to ask you, what is the trend of this graph? When you look at it, what do you see? The thing I see is that as the weeks pass, meaning as you go this way, the height increased too. So there is definitely a correlation between time passing and the height of the plant. So my trend is, as the weeks passed, right? What happened? The plant grew. The plant grew. Now that seems really obvious, and that's a trend is obvious. It should be something that you can look at a graph. Oop, that's not planet, plants. Sorry. You should be able to look at the graph easily and see what the trend is. Sometimes the trends will go down. Sometimes the trends will be flat. Sometimes it'll just go up and down, so there's no real trend. And then that's what you would say is that, you know, it's just going up and down as time went on. So let me finish my trend for this graph. As the weeks passed, the plants grew. Okay, grew. That's the trend. That's basically all it is. All right. Okay, quick summary, and my handwriting is horrible, so I apologize for that. But quick summary, line graphs show continuous data. Okay? Line graphs show a change, meaning one thing, over time. In our example here, we showed the change in plant growth over time. Shows trends. Trends meaning you look at it and you can see that over time the tree growth went up. Sometimes those trends will show downward growth, and sometimes they won't show anything and it'll be flat. And finally, lines show data that has been measured with some kind of tool. And in the case of our example, it was with a meter stick. Sometimes we will use a stopwatch. So it is measured data, unlike bar graphs, which is counted. All right, so take the notes or print the notes and then also answer the questions at the end. And we will see you tomorrow.